All right, let's go ahead and take a look at how ARP spoofing works, also referred to as ARP poisoning. Again, this is a methodology for sniffing a switched network, also defined as one technique for active sniffing. So in this case, we're going to be poisoning the ARP caches of the hosts whose traffic we want to intercept. It's going to be redirected to us. We need to talk about how ARP works, and then talk about how the cache poisoning works. We'll do our demonstration, and then we'll do a lab on it. All right, so we go to the whiteboard on this. All right, so imagine that we have a 3-port switch. All right, now again, the switch will only send traffic to the port where the MAC address that it's destined for actually resides. So our router is going to be connected to port number 1. And let's say that his IP address is 10.0.0.1. Let's say that his MAC address, which is a big, long hexadecimal number, but for ease of illustration, let's just say it's MAC 1. All right, the attacker will be connected to port number 2. We'll make this guy evil attacker. And his IP address will be 10.0.0.2, and his MAC address will be MAC 2. And our victim system will be connected to port 3. His IP address will be 10.0.0.3, and his MAC address will be MAC 3. Okay, so we have a 10.0.0.0 subnet /24. All right, so let's imagine that we have a resource out here on the internet that this box needs to connect to. So pretty quickly, he's going to determine that the IP address for the external resource is not in the same subnet. So that means he needs to send his packet to the default gateway. The default gateway will then forward it on from there based on the next default gateway, etc. So this guy has to figure out what the MAC address is for the default gateway. So he sends out an ARP broadcast. So the ARP broadcast goes out to the network. All nodes hear the broadcast, and it says something along the lines of, who is at 10.0.0.1? Please tell 10.0.0.3. So the node that holds that address responds back with a unicast response saying, that's me, and here's my MAC address. So this guy will then cache that for a period of time, 2 minutes in Windows systems, about 5 minutes in Cisco or Linux types of systems, so he doesn't have to keep re-resolving every time he wants to send a frame. So he's going to resolve and notate briefly that 10.0.0.1 is at MAC 1. All right, so the packet goes out to the internet. On its return trip, the router needs to send it to 10.0.0.3. So he's also going to need to resolve that to a MAC address. So the router throws out an ARP broadcast and then caches the response. So the response is that 10.0.0.3 resides at MAC 3. Sends the frame to the switch. Switch does its job, forwards it to the receiving host. Now, there's an interesting fact that you do not have to request an ARP resolution to get a response. It is an unsolicited ARP response and allows us to actually poison our cache. So if we poison the cache directly with an unsolicited response, the client has misinformation, which it thinks is accurate, and it's going to use that local information rather than generating network traffic. So the attacker quite simply says, hey, I am 10.0.0.1 and my MAC is MAC 2. He does the same thing to the router. I am 10.0.0.3 and my MAC is MAC 2. Is that correct? No. Do they accept it? Yes. All right, so one way to prevent that would be put a static entry in the ARP cache. That's quite a bit of administrative overhead. So as long as I keep poisoning that cache at more frequent intervals than the cache timeout, they never generate any traffic, and they never figure out that the information they have is incorrect. Once they determine that they have that local resource, they're going to send their packets to the switch. Switch just does its job. MAC 2 is over here, sends it to the attacker forwards it out to the internet, and that's how ARP poison routing works. Very cool. All right, so let's go ahead and take a look at it. We're going to be using Kane, and you'll be using Kane in the lab to perform the ARP poison routing on a local subnet. So let's go ahead and take a look at how it works. All right, so I'm going to use Kane, And I'm going to start up the network adapter. All right, and then I'm going to actually run a discovery of hosts on the local subnet. So I'll hit the plus symbol. I'll scan all hosts in the subnet and say OK. All right, so I'm actually going to poison my router. And my 2000 machine, or my 200 IP address. All right, so to prove that this is happening, let's go ahead and take a look at our victim system. And let's do a IP config, or I'm sorry, ARP-A to show the ARP cache. I'm going to ping 10.0.0.1 to generate a cache entry. All right, then we look at the ARP cache again. All right, so now he has the correct notion of the MAC address for the router. All right, so that's actually accurate. 1D is my attacking machine, which he also has an entry for. So I'm about to change both of those entries to 1D. All right, so I'm going to hop over to my 2000 machine, or 2012 machine again, and I'm going to turn on our poison routing. All right, so I'm going to add the hosts that I want to poison from the list that I just generated, 10.0.0.1 and 10.0.0.200. Say OK, hit the radioactive button, a poisoning we will go. All right, now if I take a look at my victim system, I do an ARP-A again, now both entries are the same. All right, which is wrong, but it's never going to know the difference. So now everything meant for the gateway gets sent to my attacker machine, and you see the duplicity there with the MAC addresses. All right, so let's take a look at what we can do with that once it has been established. All right, so I'm just going to do a basic send receive with a POP client. I'm going to capture a password. All right, we're actually done. Hop back over to my 2012, and now I see fully routing between the DNS server and also the mail servers. Cool. All right, now I take a look at the passwords. This is one of the nice features of Kane. It actually cleans your fish for you. So there's my POP password, Jimmy Page at itrxtraining.com, password to password. So that's immediately reusable. Any challenge response authentications, you can actually just send to the cracker. All right, so that's how our poison routing works. And we're actually going to have you do a lab at this point in your lab environment, your iLabs. Go ahead and connect to Module 7, and you're going to do Lab 4, which is ARP poison routing with Kane Enable. All right, so again, I can remotely monitor your labs. So if you run into any issues or need any nudges in the right direction, I can shadow your session. So we're going to bring these up now. So let's go ahead and take about the next 15 or 20 minutes to perform that lab. And again, I can remotely monitor you, take control if necessary.